All right, so we're starting a new chapter, and this chapter is all about inequalities, using those inequality symbols and everything. So remember that an inequality is a statement to comparing two quantities. My pen doesn't work. There we go. Comparing two quantities that are not equal. Okay, so we have all these basic inequality symbols down here that we're going to look at. But Scripture reminds us of some inequalities as well, right? We may not think of those very often, but God the Creator is greater than, right? That's an inequality, is greater than any of his created beings. Satan seeks equality with God, right? He says, I will be like the Most High in Isaiah 14:14, but he's not. Another scripture verse. Satan, in the form of a snake, told Eve that she could be like or equal to God. So is she equal to God? No, right? So it's an inequality as well. That's in Genesis 3:5. So we have these in biblical scripture that we don't always think about as math, but we could write them as a math sentence. We could say, God here is greater than created beings. What would our inequality be in the next one? Okay, who is less than? So, yeah, so we would have Eve is less than God if we wrote an inequality for that. All right, so our basic 5 inequality symbols. Okay, we have less than, so we have an example as well over there. Greater than, not equal to, is less than or equal to because it's got the equal sign there, and then greater than or equal to. Again, it has the equal sign on the bottom of it. So those are the 5 basic inequalities that we're talking about. So hopefully this part is not new to you. This part is kind of interesting. Maybe you haven't. I'm imagining you haven't done anything with that before. So placing a slash through the symbols greater than, less than, greater than and equal to, and less than and equal to results in their negation. So they're negative. Just as a slash through an equal sign means not equal to, right? So we have is not equal to. It's a little tricky though. Okay, this is a little tricky because x, so we had x is greater than 5. If we put the slash through that, so x is not greater than 5, does not guarantee that x is less than 5. Why not? It could mean that it's equal to 5. Yes. Okay, so this one says x is not greater than 5 does guarantee that x is less than or equal to 5. Okay, so we have to include the equal part if we negate it, because it could be equal to 5. Do we understand that? So if we're saying, so, right, if we say x is greater than 5, okay, well then we say, okay, well x is not greater than 5. That doesn't mean x has to be less than. It means it could be x can be less than 5, but x can also be equal to 5. So we have to write both of those. All right. So the cool thing is there's 2 ways to express these. X is less than 5 can also be expressed as x is greater than or equal to 5. So those are 2 different ones. So, but that's called a negation. So we want to, in example 1, state an inequality equivalent to each of these. So the first one's done for you. It says x is not less than or equal to y. So if you think about this, so x is not less than or equal to y, which means x has to be greater than y. Can x be equal to y? We just said it was not equal, right? Because the equal sign was in there, so we said it was not equal. So if you notice, maybe if we look at it a little differently, okay, we take this one had an inequality with the equal sign, and this one doesn't have the equal sign. In the examples we did up here, there was no equal sign, and in this one we did. So one's going to have the equal sign and the other one's not. Okay, if that helps. Yeah, so it's just the opposite, Connor. So this one says y is less than or equal to 1. So what would the opposite be, Connor? 1 is greater than 1. And this one has the equal sign, so this one doesn't need it. So that's it. Does that make sense? So Connor did a great job saying, like, it's the opposite symbol, and then one has to have the equal, has to be a greater than equal to, and the other one doesn't. So Cheyenne, how about C? What's the opposite of less than? It'd be greater than with the equal. Very nice. You got it. So it's the opposite, and then we have to, it's kind of like the slash becomes the equal sign if we don't have it. But maybe don't think about that either. All right, very nice. So far, so good? All right, then let's go to the back side. All right. Then, like equations, inequalities can be true or false. So if we look at this first one, we have 3 squared is greater than 3 times 2. So if I solve it, 3 squared is 9, 3 times 2 is 6. So we have 9 is greater than 6. Well, that's true. All right, if we solve this one, x plus 4 is less than x minus 2. This one is false, regardless of a value used to replace x. It doesn't matter what we pick. So give me a value for x. 2. Okay, so if we put 2 in there, we would have 2 plus 4 is less than 2 minus 2. 2 plus 4 is 6. 2 minus 2 is 0. Is 6 less than 0?
Yes. No.
No, this is false. Right? It doesn't matter. Give me another value for x. 10. Okay, so if we say 10 plus 4 says less than 10 minus 2. 10 plus 4 is 14. 10 minus 2 is 8. Is 14 less than 8? No, it's false. Okay, so this inequality is false. No matter what we pick for x, it's going to be false. Okay. Sure. Yeah, so give me another value for x. Negative 2 plus 4 is less than 10 minus negative 2. Negative 2 plus 4 is 2. Okay, so negative, hold on. I put the, thank you. I was like, it should have been negative 2. I was
going to say that would make it correct.
Yeah.
I don't want to disprove the formula.
Except that you really do, don't lie. Okay, is less than 2 minus 2. Oh, here we go. 2 minus 2. Ah! So 2 is less than 0? False.
2 minus negative 2. Negative. It's negative.
My goodness. We can't get it. Okay, so 2 minus negative 2 is 4. No, it's a positive 4.
Oh, yeah.
Let's see. 2 plus 4 is, negative 2 plus 4 is 2. And 2. Okay, sorry. Yes, when x, so it's false regardless of the x value used to replace x. When...
Wait, no, you messed up. Because it was supposed to be negative 2.
I was like, there's...
Yeah, because that was...
Let's start over.
Okay, so...
I keep looking at this problem over here.
Yeah,
Gracious. Okay. Right? There's a reason you don't get it. Okay. So negative 2 equals x. You're good. No. So, hold on. Shh, shh. So we've got negative 2 plus 4, right? Is less than negative 2 minus 2. Okay. It is Monday. So negative 2 plus 4 is 2. Negative 2 minus 2 is negative 4. So is 2 less than negative 4?
Yeah. No, wait.
No, it's false. Okay. So it doesn't matter. Woo. If I actually plug the numbers in correctly, it doesn't matter. But that's what happens, right? We put the number in the wrong place sometimes and it screws up our answer. All right. So again, they can be true or false. Here's the thing though. Any value that makes an inequality true is a solution, but it's any value, which means there are an infinite number of solutions to inequalities because it's any and every number less than 2 or whatever. So if we look at this example, consider x minus 3 is less than 8. Does x equals negative 2 make the inequality true? So we would plug that in. So we would say, well, negative 2 minus 3 is less than 8. Negative 2 minus 3 is what? Negative 5 is less than 8. So is that true? So this is true. So does this make the inequality true? Yes. List the values that make the inequality true. So what other values would make it true? A lot? Okay. Which ones? Any of the negatives? So negative 1, negative 2, negative 3, negative 4, negative 5. Do you want to keep going and list all of them? No, right? It goes on to negative infinity. Like, it just, that's what it's saying. We have an infinite number of solutions. Some of the positives, okay? Some positives. 8 minus 3, 8, 9, 10. And that's it for the positives. Okay, so here's the thing. We don't want to have to do this and list them all the time, which is why we're going to end up graphing them. We're going to graph solutions of inequalities. Okay, it's going to be super simple. It will, I promise.
Okay.
I'm going to show you how to do it.
Graphing this stuff was really easy. Other graphing stuff.
Okay, so let me move this up so we can look at our examples. All right.
Factoring polynomials.
So for each inequality, determine which of the following are solutions. So we're checking, this is like our set to check. So we're going to plug each of those in and check and see if it's a solution. To be a solution, it has to make the inequality true or false.
True.
True. Okay, I was like, it does have to make it true. So in the first one, we plugged 2 in. So 2 plus 3 is 5. 5 is greater than 6. Nope, that's false. So the next time we plug 3 in. 3 plus 3 is 6. 6 is greater than 6. Nope, that's false. So the next one, we plugged 4 in. 4 plus 3 is 7. 7 is greater than 6. Hey, finally we have one that's true. So 4 is a solution. Okay, I did the first one for you to have that. So let's look at the next one. Let's look at B. So 6 is greater than or equal to 2m. We're going to do it 3 times. We're going to plug in 2, 3, and 4. So 6 is greater than or equal to 2 times 2. 6 is greater than or equal to 4. Is that true or false? True. So 2 is a solution. So we're going to put it down here. We're going to do the next one. 6 is greater than or equal to 2 times 3. Now we're doing the 3 up here. So 6 is greater than or equal to 6. True. Okay, so 3 is a solution. And our last one. 6 is greater than or equal to 2 times 4 this time. 6 is greater than or equal to 8. False. So 2 and 3 are solutions. All right, so let's do the last one. Then Connor, what's the first equation going to be?
1 minus 2
Is not equal, or not less than, pardon me.
less than negative 2.
Okay, so what's 1 minus 2?
Negative 1.
So negative 1 is not less than negative 2.
True.
Negative 1 is not less than. Isn't that false? -1 is less than.
Oh, no,
right?
It's false.
No?
It's false.
It's false? Okay. You sure?
Look, okay.
You can't say
It's
no.
true because it is. It's telling you that it is greater than 2. You know.
Right, because this is really saying that -1 is greater than or equal to -2.
Oh, I didn't see the slash in the middle.
Okay, so this one is true. Okay, so if you need to rewrite it, we talked about that. You can rewrite those. That's part of why we did that first one. All right, let me change colors here for the next one. All right, Cheyenne, give me the next problem.
1 minus 3 is
Not less than.
not less than -2.
Okay, so what's 1 minus 3? -2. So -2 is not less than -2. So true. So I'm going to rewrite this, and we're going to say -2 is greater than or equal to -2.
Yay.
True. All right. And Bailey Malin, how about the last one? Okay.
Jinx.
Bless you.
Last one.
Uh-huh. So we did 1, or we did 2, we did 3. So now we're ready to do 4.
So 4. 1 minus 4 slash
1 minus 4 is
less than.
not less than.
Greater than?
No, it says, that's what it says. Not less than. We have a slash through it, right? It's the less than. Nope. I'm not correcting you. I'm just trying to help you read it.
Okay.
Is not less than. Not 2. It's -2.
-2.
Okay. What's 1 minus 4?
-3.
Okay, so -3 is not less than -2. Or we can say, well, -3 is greater than or equal to -2, and that is false.
You can also tell by
So-
context clues that it is false right away.
Well, she requires
English class is next.
Context clues don't work in math.
2 and 3 are solution.
So 2 and 3 are solution, yes. I'll write it up here this time. So 2 and 3 are solutions. Good.
I don't know why it's so it's confusing to look at the paper and then look at the board and for some reason it makes me lose my spot every time. I can never find it.
Oh, I'm sorry. That is a bummer. Okay. So usually it's not possible to list all the solutions to an inequality. So they are graphed on a number line. And we just talked about that up above before. So to avoid confusion in this, inequalities are written with the variable on the left. Okay. So here's the thing. If we have 5 is greater than x, we're going to rewrite it as x is less than 5. So essentially you're reading it like from the right. Because if you did that, it requires you to flip the sign, right? X, if you read it from this way, x is less than 5. So to rewrite it, we're flipping the sign. Okay, we flip everything. So what would that last one be if we rewrote it?
It would be x is less than or equal to -2.
Okay, did we flip everything?
No.
We did not.
It needs to be x is greater than.
Yep, needs to be x is greater than.
No equals.
No, it does have the equal sign still. Yep.
X is less than or equal to.
Yeah, we're not negating it
That's not how it was on the first one.
because we're flipping it. That's what I'm saying, Cameron. We have to flip everything, including the sign. It's not like an equal sign. The sign has to be flipped because if I was reading it from the opposite direction, like here, if I would say x is, oh, that's a less than sign pointing. X is less than 5. That's how I have to write it. Or I have to think about, I have to take the sign and flip it if I flip it over.
I think Karen was thinking you were doing the same thing from the very beginning.
Yeah.
Okay.
That's where
Could be. So, but this is going to avoid confusion when it comes to graphing if you always have your variable on the left. Okay. All right, so on to the graphing, page 3, how we graph inequalities. Okay, so there are some shortcuts here to graphing. So first of all, if you have a less than or greater than, you're going to have an open circle. If you have the equal sign with them, so less than or equal and greater than or equal, you're going to have a closed circle on your number line. If it's less than or less than and equal to, we're always going to have our arrow to the left because it goes the same direction as our inequality does. Our inequality points to where the arrow goes. Okay, so if we have greater than or equal to, we're going to have an arrow to the right. The caveat, this only works if your inequality is written with the variable on the left. It has to have the variable on the left. Otherwise, these shortcuts will not work. Then you rewrite it like we just did on the previous page, right? We had -2 is less than or equal to x or something like that. So we want to say, well, x is greater than or equal to -2. So we move to opposite sides, right? The x came over to the front, to the left, the -2 went to the right, but our sign flipped. It went from less than and equal to greater than and equal to. So all you have to do is rewrite it if it's not on the left. All right, so let's actually do that. So this first one, again, it's done for you. It's greater than or equal to, so I have a closed circle. Okay. And then it says it's the arrow, right? Or our symbol is pointing to the right, so our arrow goes to the right because it's the numbers that are greater than. So those are the two keys you pick up there. Is the circle open or closed, and which direction? Because we just graph it on a number line. Okay, so I've given you the number line on all these. So for the next one, what will we do for B? -1 is less than x. It only works if the variable is on the left.
So we need to fix that.
We need to fix it. The variable's not on the left, it's on the right.
So it would be.
So flip it. Bailey, what would it be flipped?
X is less than or greater than -1.
All right. Okay, so now we've got variable on the left. Check. Now, Connor, what were you going to tell me? Not at 0. Okay. It would be the open circle is always connected to the number that's there. So the circle was at -3 here. So our open circle is at what, Connor? -1. Okay. But -1 is our focus. Like 0, that's the number that we do know. That is one of the solutions.
The closed circle means this. The closed circle means you're not where it's on, but the closed circle means you are.
So, okay, and then it's going to the right. Our arrow is going to the right. So 0 is a solution because 0 is greater than -1. The only thing that's not greater than -1 is -1 and below. If you had -1.2, or sorry, if you had -0.8, that would be greater than -1. All right, how about C? It's a little tricky. C is a tricky one. Well, it's okay. It would be on both sides. Yes. So this one says x is not equal to 55. Open circle. And it's not equal. So it's any number but 55. Okay. So it's a tricky one. I mean, a little bit. It's easy to graph, but like to think about it, it's not in any of like the shortcuts here that we talked about.
We did this a lot last year.
So if it's
Good.
If it's an equal sign, it's an open circle.
If it's an equal sign, it's a closed circle because that's what it equals to. But this is a not equal sign. That's why, again, it's kind of tricky. Like it doesn't, because it's not the answer. Because the closed circle means that number is included. Okay. All right. So then example 5, write an inequality to describe the graph. Then write an equivalent negated inequality. So what inequality would represent this graph?
Less than or equal to 80.
Less than, okay. right? Because it's or equal to because it's closed in. Good. So we need x is less than or equal to 80 because that's the number of focus. Great. So then what's the negated inequality? Mm-hmm.
Would it be x is less than 80? It's greater than 80, not less than.
Okay, so remember, yeah, because negated means x is not less than equal to 80, right? If we negate it. And so that means that we talked about earlier, we essentially flip the sign. So that would be x, oops, not 8. X is greater than 80. So that's the negation. So this is the inequality for the line, and the negated one is the x is greater than 80. Perfect. All right, then the lovely word problems are next.
Woo!
It's actually not a word problem.
Aren't you so happy, Jesse?
All right.
Josie.
That's not nice.
Oh, no. Hey, Josie was a donut.
Oh, the donut over there.
Donut.
Okay, so it's actually not a word problem, but it is like critical thinking.
So would we do the graphing on here?
Nope. Because it says define a variable and write an inequality, modeling each solution. So the first one, I said, I defined my variable right here. Let C, that's my variable, equal the cost of an item. And then my inequality, since my clearance, okay, is $9.99 and up, C has to be greater than or equal to $9.99. Because it's equal to $9.99 and up, so greater than. So how about B, the maximum occupancy not to exceed 225 persons.
Oh.
So we need to define a variable.
Oh. It's C is.
Okay, why would you pick C?
P is less than.
Okay, but what? No, we have to define the variable. We need to follow the directions. Define a variable.
We should use P because the variable is going to be people.
So let P equal, okay, the number of persons or people or humans, whatever. Okay, so there, we defined our variable. Now we can say, well, then P
is less than or equal to 225.
less than or equal to 225. Good, because it can equal 225, right? Because it says not to exceed. So it can be equal to 225, but it can't be over that. Perfect. All right, then you can get started on your homework.
This homework should be pretty easy. It's a lot simpler compared